Hello everyone. Today we are going to discuss the problem chocolate distribution problem. So it is a difficulty easy question. So coming to the problem description, given an array ARR of positive integers. So where each value represents the number of chocolates in a packet. So each packet can have a variable number of chocolates and there are m students. So our task is to distribute the chocolates among the m students. So the rules are each student should exactly get only one packet of chocolates and the difference between the minimum number of chocolates given to a student and maximum number of chocolates given to a student. This both difference should be minimum so that minimum possible difference will be our output. So by distributing each packet to the m students, the minimum possible packet chocolates and the maximum distributed number of chocolates in a packet should be least or minimum. So if we observe with the test case more clearly, so the input is 3, 4, 1, 9, 56, 7, 9, 12 and the number of students are 5. So m is equals to 5. So if we observe in our input the ARR, we cannot decide easily, but if we keep them in the ascending order, then what are the first 5 values? They are going to be 1, 3, 4, 9, 9. So this is the first set of the values. So in this way, if you keep on the next set of the values continuously, so we will get anywhere the least possible difference. So we will explain this in the code in detail or the dry run case. So coming to the complexities, the time is big of n log n, space is big of 1. So we should not use any extra dynamic space. We can use some small variables, it is acceptable. So company we can see. These are the topics related to sorting and algorithms. So now first explain what is going on in this question. Soon we will be using some stylus kind of thing to write and explain in a whiteboard. So our approach is, first let us discuss with an example to better understand the question so that we can easily do our work. So we will take the first example only. So 3, 4, 1, 9, 56, 7, 9, 12. So they are the elements, right? So first we are going to make this whole elements or the number of chocolates in the ascending order. So the order is 1, 4, 9, 9, sorry, there is a 7, 7, 1, there is also value 3, 3, 1, 3, 4, 7, 9, 9, 1, 3, 4, 7, 9, 9, 12, 56. So they are the values, right? So what are the children's? There are total 5 students. So if you see the count of numbers 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So the total number of packets are matching. So they are the ascending order of the given first example. So we'll first arrange them in the ascending order. So now we start with the first set of batch of m students in the given packets. So they gave the m is equals to 5. So let us take the starting from the first position 5 packets sequentially. So what are the batch 1 of packets are 1, 3, 4, 7, 9. So is it batch 2 is equals to, so now the batch 2 will start from one position after the first batch. So it is 3, 4, 7, 9, 9. Now batch 3 also one position after the batch 2, which is 4, 7, 9, 9, 12. Batch 4 is equals to 7, 9, 9, 12, 56. So we reached the end of the packets. So total we got around 4 batches. So this is how we are going to solve this program only. So first we will arrange them in the ascending order, and with the batch size of m, the number of students, we take the batches starting from the first packet to the m size, and then sequentially going the next batch and next batch like that. So we got 4 batches. Now we find the difference of the minimum least possible packet given and the maximum number of packets or the chocolates in the packet given to a student. So then the first one, what is the maximum? It is 9, minus what is the minimum? It is 1. So 9 minus 1 is equals to 8. So we got the difference from the batch 1 is 8. So in the second batch, 9 minus 3. This is the second batch, which is 6. So same, third batch, 12 minus, it is 4. It is 8. So batch 4 is equals to 56 minus 7. It is 49. So we got the difference of maximum number of chocolates in a packet and the minimum number of chocolates in a packet of all the batches here, 8, 6, 8, 49. So the output they said to be written the minimum possible difference. So what is the output from the minimum value is 6, 8, 8, 49. So 6 is the minimum. So we can see the output is 6 here. So this is how we are going to solve this program. First we arrange them in the ascending order, and with the batch size of m, we continuously extract batches one by one from the given array, like 1, 2, 3, 4, 5 elements, batch 1, and after one element starting again like this and like this and like this, like that. So we got the 4 batches in this case with the batch size of m and this array, and we found the difference in that batch, and we extracted the least difference from that. So there is a name for this kind of approach or this kind of problems. So it is sliding window. Sliding window refers that if there is an array and we have a window size of m, let us say in this case we have the window size of 5. So the first window is this one, as we know, 5 elements. So sliding window, the name suggests that we first initialize a initial window which is 1, 3, 4, 7, 9, and we slide it one step at a time. So as we saw here the batches, this we call now as a window. So it was started from the here. So one step after moving the window to the right or the end, it is 3, 4, 7, 9, 9. This is the second window. And if you move again one step further, this is the window, and at last this is the window, and we stop because we reached the last element. So this is how we check using the each windows and compute some required value from that window each time and compute the output. So this approach is called as a window, sliding window, in which we So this is what the sliding window is. So we move a window of size m through the array step by step and compute the result. So it is like a window. So we say the above, the batch 1, 2, 3, 4, sliding one step at a time forward. So in this approach, we also discussed how we are going to do this. So see the things used. Obviously we are going to use the loops, variables, and condition statements. Mostly these only we are going to use. So now how we are going to use this values. So we discussed with an example how our approach is going to work, and we discussed what is the approach. It is a sliding window, and also what are the things we are going to use. So now let's see in the program how to do it. So there is a base case. So if you think with the mind, we see that if there are no students, like m is equals to 0, then there are no packets distributed among the students, then obviously the output is 0. Or there are students, like let us say m students, n students, 1000, 10,000, some number, but there are no packets. There are no packets of chocolates to distribute. So in that case also the output is 0. So if there are no packet to distribute, or there are no students to give the packets, in this both cases we can't actually calculate the minimum and maximum possible, because we can't give the chocolates to the students, or we don't have the chocolates. So before computing, just handle that case. So we get the length of the array in array list using the size method. If size is equals to 0, or the number of students is equals to 0, in either case the output will be 0. So over. Now we saw the actual logic is going to be implemented. So we saw that first we are going to arrange that in the ascending order. So we are using the collections.sort method inbuilt one, which has the time complexity of n log n. So now we said we will store the minimum possible difference in the variable like minimum d. Min d is minimum difference is equals to data initialize this value with the maximum possible value, so that any value can be by default minimum with this value. So later we will be updating the min difference value, but initially it should be the maximum possible value, so that any value which comes will by default be the minimum value comparing to it, the integer value. So now for int I is equals to 0, I less than, so let us declare the size here, int n, which is the length, is equals to arrow dot size, I less than n minus m. So as we are going to use the sliding window, if you see in this case, the example case, we know that if the now here the I is the starting index of the each window. So in this case, what is the index of 7? It is 0. We should see in this 0, 1, 2, 3. So 3 was the index. So what is the, how can we get that value? So length is 8. So 8 minus 5. So n minus m is the starting index up to which the indexes are the windows are actually valid. So we calculate the difference. Difference is equals to array dot get of I plus m. So if you see in this case, I plus m means I is 0 obviously. So 5 means 0, 1, 2, 3, 4 only. So we can just add here the minus 1. I plus m minus 1 minus array dot get of I. So maximum number of chocolates in a packet minus minimum number of chocolates in a packet. So after this we just check if our minimum D is greater than this current difference. If it is, then minimum difference is equals to difference. So simply return the output as a minimum difference. So you can see the sample test case is passed. So we got a small problem. So now we need to solve this problem. How? So 11, 13, 7, 5, 13, 12. The output and the number of students are 4. So our code output is 6, as they said. So if you see in this 5, 7, 12, 13, 13. So the chocolates we should distribute are the 4. So 12. So let us write here. Let us just see first how it is going to be. So if we sort those values, five, 7, 12, 13, 13. So 5, 7, 11. There is 11. 5, 7, 11, 12, 13, 13. So in this case, this window, if you see the last window, we can see here 0, 1, 2, 3, 4, 5. But there are 6 numbers. So if you see the batch of 1, it is this one. So the difference is 7. So in this case the difference is obviously there is 6 and the last window which is 2. So our window is stopping here only but not going to the last window possible. Then you can just simply add here plus 1. So this is how we also do the debugging by simply writing that. Sorry, I resubmitted the program. So we can see the hidden test cases are also passing. So now if we analyze the time and space complexities, this loop inside doesn't have any another loop, so this loop takes big of n. So you all know any sorting algorithm on an average in the Java takes n log n. So there are some small variables which all take big of 1, big of 1, here also variable big of 1. So all are the big of 1 only. So if we see the time in total, big O of n and big O of n log n. So n log n plus n. So which is bigger? N log n only. So overall the time will be big O of n log n. So if you are adding all the big O of 1, 1, 1, 1, etc., the output is also of the space is big O of 1. So now if you compare, so we can see the time complexity is big O of n log n, so it is matching, and the space is also big O of 1, which is also matching. So this code expected and the actual are also matching. So this is how we need to write the program for this kind of problem. So we need to analyze and say that by seeing the problem under which category it comes. Like we saw, because of this batch kind of thing with a fixed size, it is comes under the sliding window technique. So we need to find the technique under which it comes and then apply that technique with some modification so that we can solve this program. So this program link is given in the description. Kindly go and practice the problem. Thank you for watching. Kindly subscribe.